They tamed a forest the size of a continent. While America logged with caterpillars and chainsaws, the Soviets built monsters on tank chassis, tracked beasts that crushed through frozen Siberian taiga where no Western machine could survive, skidders bred from battlefield armor, forwarders that swallowed whole trees. For decades, these forestry giants stayed hidden behind the Iron Curtain, conquering the largest woodland on Earth in total silence. Here are 10 machines America never saw coming. Number 10. The MEZ 509 logging truck. Before specialized forestry monsters took over the taiga, Soviet logging depended on something brutally simple: giant all-wheel drive logging trucks that could survive roads that barely existed. And few became more legendary than the MEZ 509. Built by the Minsk automobile plant during the 1960s, the MEZ 509 was engineered specifically for timber hauling in the harshest regions of the Soviet Union. This was not a highway truck. It was a deep forest machine designed to crawl through mud, snow, frozen river crossings, and roads that turned into swamps every spring. Its six-wheel drive system, enormous ground clearance, and locking differentials made it one of the few wheeled vehicles capable of reaching remote Siberian logging camps year-round. What made the MEZ 509 especially fascinating was its logging trailer system. The truck could carry its own disassembled trailer directly behind the cab when traveling empty, then deploy it deep in the forest to haul massive tree-length logs back out. Soviet engineers designed it this way because many logging routes were so rough that hauling an empty trailer both ways wasted fuel and reduced mobility. Under the hood sat a massive Yams diesel engine producing around 200 horsepower. Enormous power for a Soviet off-road truck of its era. The machine became famous for reliability in extreme cold, where temperatures regularly dropped below -40 degrees Celsius. Drivers often left the engines idling for entire shifts because restarting a frozen diesel in the middle of Siberia could become a life-or-death problem. For decades, the MEZ 509 became one of the defining images of Soviet timber extraction. Long convoys of these trucks hauled entire forests across frozen winter roads, while clouds of diesel smoke rolled through the taiga. Even today, restored examples still appear in Russia's logging regions, surviving as mechanical relics of one of the largest forestry operations on Earth. Number 9. The TDT-40. In 1956, by a USSR government regulation dated the 30th of January that year, production of the design was transferred to the Onega tractor plant in Petrozavodsk in the Republic of Karelia, and the machine was given a new designation, the TDT-40. This single decision is one of the most important moments in the history of Soviet forestry because it turned the Onega tractor plant into the beating heart of the entire Soviet logging machine industry. The plant itself has an almost unbelievable history. It traces its origins all the way back to the 29th of August, 1703, founded in the era of Peter the Great, originally as a metallurgical and arms works. 2.5 centuries later, it reinvented itself as the USSR's premier builder of forestry tractors. Production of the TDT-40 at Onega commenced in 1957, marking the plant's full entry into heavy forestry machinery manufacturing under the Ministry of the Tractor and Agricultural Machinery Industry. The TDT-40 was a tracked skidder designed for one brutal purpose: dragging felled timber out of cutting areas across terrain that no road could cross. Its engine was adapted from existing Soviet tractor power units, and it was rated for towing in the harsh, impassable northern regions where it would spend its life. It became the workhorse of countless Soviet logging operations through the late 1950s and into the 1960s. But the TDT-40's greatest legacy isn't the machine itself, it's what it made possible. By concentrating Soviet forestry engineering at Onega, it created an institution that would, at its peak in 1985, account for roughly 19% of the entire Republic of Karelia's industrial production and export machines across the socialist world. America never saw the TDT-40, but the taiga was reshaped by it. Number 8. The TDT-55. If the TDT-40 built the industry, its successor became a legend that simply refused to die. Onga's engineers knew the TDT-40, for all its importance, was becoming outdated, so they began a program of studies and calculations, and by 1962 the first TDT-55 had been assembled. It went through a battery of tests, and in 1964 the decision was made to launch a production line. In 1966, the fully refined, reliable TDT-55 began rolling off the assembly line. What makes the TDT-55 a giant worthy of this list is its staggering longevity. Production of this tracked tractor at the Onega plant continued all the way until 2003, a production run of roughly 37 years, spanning the entire late Soviet era and surviving more than a decade into post-Soviet Russia. Across that run, it received several successful upgrades, including the well-known TDT-55 M1 Jets variant, which can still be found working throughout Russia today. The engineering brief for the TDT-55 reads like a survival manual. It was built to operate reliably through temperature drops from -40 to +40 degrees Celsius. It was designed for genuine off-road use, for working on mountain slopes, and for moving across swampy, load-bearing challenge soils where a wheeled machine would simply sink and disappear. It was classified in the 3rd traction class, giving it the muscle to drag serious loads of timber. This is the machine that, more than any other, defined what a Soviet skidder was. Rugged, tracked, simple enough to repair in the field with basic tools, and tough enough to outlast the very nation that designed it. Decades after the first one was built, TDT-55s are still hauling logs across Russia, a kind of mechanical immortality that almost no Western forestry machine of the same era can claim. Number 7. The TT4. While the Onega plant in the European northwest of Russia turned out the TDT family, a second giant was being built far to the east, at the Altai tractor plant. This was the TT4, a Soviet-tracked skidder of the 4-ton traction class and a heavier, more powerful beast than its Onega cousins. The TT4 was designed for a specific and demanding technique called choka skidding. The machine would gather a package of whips, full tree stems or whole trees, secure them, and transport them in a semi-submerged state, with one end dragging and the bundle partly lifted off the ground. This method let a single machine move an enormous volume of timber in one pass, which was exactly what the vast Siberian logging operations needed. With a power output in the region of 120 to 125 horsepower and a working speed of around 17 kilometers per hour, the TT4 brought serious tractive force to the largest forests on Earth. The TT4's significance goes beyond its own service, though. Its running gear, the track chassis and undercarriage, proved so capable that it became a foundational building block for other, even more specialized machines. As we'll see in just a moment, when Soviet engineers wanted to build a fully mechanized tree-felling monster, they reached for the TT4's chassis as the starting point. For decades, the TT4 was the muscle of Eastern Soviet forestry, the machine that did the heavy dragging across Siberia's endless cutting blocks. It was so iconic that, generations later, it became a beloved staple in off-road simulation games, a digital monument to a machine that most Americans have still never heard of. Number 6. The Belarus MLH-104 harvester. By the late Soviet and post-Soviet era, forestry was evolving from brute force into full mechanization, and machines like the Belarus MLH-104 represented that transformation. Built in Belarus for industrial logging operations across Russia and Eastern Europe, the MLH-104 is a modern harvester designed to do the work that once required entire crews of lumberjacks. A single operator sitting inside a climate-controlled cab can grab a standing tree, cut it at the base, strip the branches, measure the trunk electronically, and cut it into perfectly sized logs within seconds. The machine rides on a massive articulated chassis with gigantic forestry tires or optional tracks for swamp conditions. Hydraulic power drives everything: the crane arm, the harvester head, the feed rollers, and the computerized cutting systems. Watching one work almost feels unnatural. Trees disappear with assembly line efficiency. What makes these harvesters especially impressive is where they operate. Russian forestry isn't clean Scandinavian woodland. Much of it is remote taiga filled with bogs, deep snow, collapsing roads, and brutal winters. Machines like the MLH-104 are specifically engineered for those conditions, with reinforced frames, insulated hydraulics, and systems designed to start in extreme cold. The operator environment is another world compared to older Soviet forestry machines. Earlier skidders and crawlers exposed workers to deafening noise, freezing temperatures, and constant vibration. The MLH-104 instead uses panoramic visibility, ergonomic joystick controls, onboard computers, and suspension seating to let operators work long shifts with far greater safety and precision. These harvesters symbolize how Russian forestry evolved from raw mechanical power into industrial-scale automation. The giant tracked skidders of the Soviet era dragged trees out of the forest. Machines like the MLH-104 process the forest itself. Number 5. The Kirovets K-700 in Soviet logging. Most people think of the Kirovets K-700 as an agricultural tractor. But in the Soviet Union, this gigantic articulated machine became something far more versatile, including one of the most important logging tractors ever used across remote forestry regions. Introduced in the 1960s, the K-700 was enormous by Soviet standards. Its articulated frame gave it incredible maneuverability despite weighing over 12 tons, while its massive tires allowed it to cross mud, snow, and soft forest terrain that trapped ordinary trucks almost instantly. Powered by a huge V8 diesel engine, producing over 200 horsepower, the K-700 delivered enough pulling force to drag heavy timber loads through undeveloped wilderness. In forestry operations, Kirovets tractors were often fitted with specialized logging equipment, including winches, grapples, and timber trailers. They became especially valuable in areas where tracked skidders were too slow but ordinary wheeled trucks couldn't survive. The K-700 occupied a perfect middle ground, faster than crawlers but vastly tougher than conventional road vehicles. The machine earned an almost mythical reputation among Soviet operators. Drivers described the tractor as unstoppable. In winter, Kirovets machines hauled timber across frozen rivers and temporary ice roads. In spring, they churned through mud so deep it reached the wheel hubs. Entire logging settlements depended on them to move wood, fuel, and supplies across regions with virtually no permanent infrastructure. The cab itself reflected Soviet priorities: rugged, simple, and built to survive punishment rather than provide luxury. Noise, vibration, and heat were constant companions, but the tractor's durability became legendary. Many K-700s remained operational for decades with only basic field repairs. Even today, the giant yellow Kirovets remains one of the most recognizable machines ever built in the Soviet Union. And in Russia's logging regions, it still carries the reputation of a forestry beast that simply refused to stop. Number 4. The Ponsse Bear of Russia's taiga. One of the biggest surprises in modern Russian forestry is that some of the most advanced logging machines working inside the taiga aren't Russian at all. They're Finnish, and few are more respected than the Ponsse Bear. The Ponsse Bear is one of the largest and most powerful harvesters ever built for cut-to-length logging. Designed in Finland specifically for northern forests, the machine found a natural home in Russia, where logging conditions often push equipment beyond its limits. Deep snow, swampy terrain, endless distances, and brutal winters make the Russian taiga one of the harshest forestry environments on Earth. The Bear lives up to its name. Weighing well over 20 tons and powered by a massive diesel engine, the machine uses an articulated 8-wheel chassis that spreads its weight across soft ground while maintaining incredible traction. Mounted at the front is a giant hydraulic boom fitted with a computerized harvester head capable of cutting, delimbing, measuring, and processing entire trees in seconds. Modern systems inside the machine constantly calculate log length, timber volume, cutting optimization, and fuel efficiency. Compared to older Soviet-era forestry equipment, the technology feels almost futuristic. Yet despite all the electronics, the Bear is still fundamentally built for survival. Reinforced frames, protected hydraulic lines, heated systems, and extreme cold engineering allow it to work through conditions that would destroy ordinary construction machinery. Russian logging companies adopted these harvesters because productivity matters enormously in forests that stretch for thousands of kilometers. A single modern harvester can replace massive crews of older equipment while operating with astonishing precision and speed. The sight of a giant Ponsse machine processing trees deep inside Siberia captures the evolution of forestry itself, from raw Soviet brute force to highly computerized industrial harvesting on a continental scale. Number 3. The Amkodor forwarders. To complete the picture of post-Soviet forestry giants, we have to cross into Belarus, a former Soviet republic, and look at Amkodor, a machine-building holding based in Minsk, with a history stretching back nearly 90 years, from a small factory into a major industrial association with more than 90 models and modifications in its range. Amkodor is fascinating because it deliberately built machines for both of the world's competing logging philosophies. There are two dominant techniques in modern forestry: the cut-to-length method, sometimes called the Scandinavian system, and the tree-length or full-tree method, often associated with North America. The cut-to-length system relies on a pair of machines working together: a harvester that fells the tree, strips its branches, and cuts it into measured logs right there in the forest, and a forwarder that gathers those logs and carries them, fully loaded off the ground, to the roadside. Amkodor builds both halves of that partnership. Its harvesters, like the compact 2531 model, handle felling, delimbing, and bucking. Its forwarders, like the FF560 and the 2682, are designed for collecting, loading, and transporting timber along logging roads, plus sorting and stacking at the landing. These are sophisticated machines. The FF560 features a load-sensing single-pump hydraulic system with an adjustable pump, an articulated steering frame with hydraulic feedback, multi-disc brakes running in oil, and a cargo compartment with a substantial cross-sectional area for hauling round timber. The significance here is competitive. Amkodor explicitly positions its machines to compete with foreign equivalents on quality and performance, while undercutting them dramatically on price, both the price of the machine and the cost of spare parts and service. For a logging operation across Russia and the broader region, that combination is exactly why a homegrown forwarder beats an imported one. These are world-class machines hiding in plain sight, and most American loggers have never seen one in the flesh. Number 2. The John Deere 848 skidder. In Russia, it may sound strange to imagine an American forestry machine becoming a giant of Russian logging, but that is exactly what happened with the John Deere 848H skidder. As post-Soviet forestry modernized, Russian companies increasingly searched for machines capable of combining Western productivity with the toughness required for taiga operations. The 848H quickly earned a reputation as one of the few wheeled skidders capable of surviving those conditions. The machine is enormous. Its articulated frame, gigantic forestry tires, and heavy-duty grapple allow it to drag huge bundles of logs across rough terrain at surprisingly high speeds. Unlike older Soviet-tracked skidders that relied mainly on brute traction, the 848H combines modern hydraulics, balanced weight distribution, and advanced driveline systems to move efficiently through mud, snow, and uneven ground. Inside the cab, the contrast with older Soviet forestry equipment is dramatic. Operators work in climate-controlled conditions with panoramic visibility, ergonomic controls, advanced monitoring systems, and significantly reduced vibration and noise. In regions where shifts can last 12 hours in extreme cold, those improvements matter enormously. Russian operators particularly valued the machine's reliability and serviceability. Forestry work deep in Siberia punishes machinery relentlessly. Long distances, freezing temperatures, overloaded trails, and non-stop operation destroy weak equipment quickly. The 848H developed a reputation for enduring abuse while maintaining high productivity. What makes this machine fascinating in the context of Russian forestry is what it represents: the collision between two logging worlds. Soviet forestry once evolved in near-total isolation behind the Iron Curtain. But by the 21st century, Western and Russian technologies were operating side by side in the same forests, hauling timber across the same frozen roads. The result is one of the strangest sights in global logging. American-built skidders working inside the same Siberian wilderness once dominated entirely by Soviet-tracked monsters. Number 1. The John Deere 1270 harvesters of the Russian taiga. In the end, the greatest forestry giants working inside Russia's endless taiga weren't always Soviet machines at all. By the 21st century, some of the most feared and respected logging monsters in Siberia came from an American name recognized across the world: John Deere. And among them, few became more iconic than the John Deere 1270 harvester. This machine represents the absolute industrialization of forestry. What once required chainsaw crews, skidders, loaders, and multiple operators can now be done by a single machine, moving through the forest like a factory on wheels. The 1270 grabs standing trees with a massive hydraulic harvester head, cuts them at the base within seconds, strips the branches, measures the trunk electronically, and slices it into perfectly calculated logs before the tree even hits the ground. Watching one work inside the Russian taiga feels almost unreal. Giant pines disappear with machine-like precision while onboard computers constantly optimize cutting length, timber value, and fuel efficiency in real time. But what truly makes the 1270 worthy of the #1 spot is the environment it operates in. Siberian forestry is among the harshest logging environments on Earth. Winter temperatures plunge below -50 degrees Celsius. Roads collapse into mud every spring. Entire operations may sit hundreds of kilometers from the nearest major town. Any weak machine simply dies there. The 1270 was engineered specifically for those conditions. Massive articulated frames allow it to maneuver through dense forest while maintaining stability on uneven ground. Reinforced bogie axles spread the machine enormous weight across soft terrain. Heated hydraulic systems, insulated operator compartments, and heavy-duty drivetrains keep the harvester working through conditions that would cripple ordinary equipment. Inside the cab, the contrast with old Soviet forestry machines is staggering. Operators sit in climate-controlled suspension seats, surrounded by digital displays, joysticks, and panoramic glass, while the machine performs work that once demanded entire logging crews, risking their lives with chainsaws. And this is what makes the story so fascinating. For decades, Soviet forestry evolved behind the Iron Curtain with its own isolated ecosystem of tracked skidders and brutal mechanical crawlers. But modern Russia eventually embraced highly advanced computerized harvesters like the 1270, because efficiency on a continental scale demanded it. Today, these giant harvesters roam forests stretching thousands of kilometers across Siberia, processing timber with a speed and precision that earlier generations of Soviet loggers could barely have imagined. They are the final evolution of mechanized forestry, industrial giants harvesting one of the largest forests on Earth. If you found this fascinating, you're not alone. This is a whole world of machinery that deserves far more attention than it gets. Let me know in the comments which of these giants surprised you the most, and whether you'd like a deeper dive into any single one of them. Don't forget to like and subscribe for more hidden stories of the machines that built and harvested the modern world. Thanks for watching.